Here we go. And this is the fifth video. I've got three examples here, and I think that I want to represent this guy as vector A, this guy here as vector B, and this vector here as vector C. And I'm simply going to ask that we take a look at this and resolve each vector into its components. All right, so let's start, and I'm going to do this in a different color here, blue. So let's take a look at case A for vector A. Vector A can be expressed as the addition of its two orthogonal component vectors in the x and y direction. So let's take this one step at a time and say, what vector component does A have in the x direction? Now you may say, well, gee, how can we figure that out? Well, if you look at the diagram here, or the coordinate axis that I drew, and you drop down a perpendicular, you see that we have this component here is simply 3 units in the x direction. So we can express this vector here as 3 I hat. That's I hat is the unit vector in the x direction, and it has a magnitude of 3. 3 times the unit vector of 1 will give you this vector here. The y component direction has a magnitude of 2. Right? We just go draw our little box here. So here's vector A. It's composed of two vectors, one of length 3, one of length 2. So we're going to add, if we add those two perpendicular vectors together, this is 2 and it's J. J is the unit vector in the y direction. So there you have it. This is the representation of vector A. Vector A is the combination of its components, the I component and the J component. And so from now on, I'll just be calling the component not as the X or Y component, but I will call them as I component or the J component, because that's the unit vectors, and any vector can be depicted or by determined from the resultant combination of all of its individual component vectors. So this is vector A. Now if I want to know what is the magnitude, the question is the magnitude of A. What's the magnitude of A? Sometimes we show magnitude as an absolute value sign. And for magnitude is going to be very easy to find. We simply take the I component and square it. And then we take the J component and we square it. And we get the 3 squared is 9 plus 4 square root of 13. That's the magnitude. What's the angle? Here's our angle here. Angle theta will be the inverse tangent of the J component over the I component. So it's the inverse tangent of the J component over the I component, because the J component is the opposite, the I component is the adjacent, and tangent of theta is opposite over adjacent. So if our tangent of theta is opposite over adjacent, then the inverse tangent of opposite over adjacent will give us the angle. And that's what we're looking for. So in this case, we've got the magnitude, and we've got the angle, and we've got complete representation of vector A. So we wrote it in its component form using the unit vectors I and J, because remember, any vector can be multiplied by any scalar, and we simply use this I as the unit vector. It has a magnitude of 1, so if we multiply 3 times it, it represents this vector right there. Let's look at case number 2 with the vector b. So b is going to be what? Well, in the x direction, we have an I component of simply 1. We have a j component of 2. So this is going to be I plus 2j. It's understood that there's a 1 in front of the I, because I is a unit vector. And in this case, you're only out one unit, one magnitude. So your unit vector is just, that's all it is. So this is the vector representation for B. It's I plus 2j. If I want to know the magnitude of vector B, shown like that, it's going to be the square root of the I component squared, which is simply 1 squared, plus the j component squared, which is 2 squared, which in this case will be the square root of 5. The angle will be inverse tan, and you simply take the j over the I, so it's 2 over 1. So we got the angle, we got the magnitude for that one. Okay? Now the last one, I deliberately shown something that's off in a negative type of direction for x and y. What is the unit vector for vector c? So let's see, vector c in the x direction is going 1, 2, 3, 4. So there's negative 4. It's 4. Actually, it's 4 in this direction, in the negative direction. So this is going to be negative 4 times I. I is this guy right here, I hat, 1 unit in this direction. So if we multiply this vector by a negative 4, we're going to say it's 4 times this unit vector, but it's in the opposite direction. So vector c is going to have a I vector representation, unit vector representation as negative 4i. But now look, it also is traveling downward 1, 2, let's say 3. That's 3. So this is down 3 units. So it's minus 3j. J is the unit vector up. In this direction, we want to take the negative of the vector, so it points downward, and we want to multiply by 3. So we'll just take a look at that, because this is important to understand as the representation for this vector c. It's got a magnitude of 4 in the negative x direction. Magnitude negative 4. X direction is represented by I hat. Y direction represented by j hat, and it's going down, it's in a negative y direction. Okay, so magnitude of vector c is the square root of negative 4 squared plus negative 3 squared. So what will that be? That's the square root of 16 plus 9, which is the square root of 25. Is it? Yes, which is 5. The angle here would be the j component inverse tangent. By the way, this was inverse tangent, not tangent. Inverse tangent of the j component, which was negative 3, over the x component, which is negative 4. And what angle we're talking about in this case is this angle right there. Okay, so that's how we do vectors. And that's all there really is to it. Now in 3 dimensions, let's see, just to be neater, here is 1, 2, well, Not so good. Okay. If this is X and this is Y and this is Z, something like this, this could be the I direction, this could be then the J direction, and the unit vector in the Z direction is represented by K hat, IJK, okay? So 3 dimensions works the exact same way. I don't want to confuse you with that here, but there's no big deal about it. It's a point in space. I draw a point in space and draw a vector to it. The vector can be represented as an I component, a J component, and a K component. And you would do it exactly the same way. And we'll do that in the next video.